Hello, it's Mr. O'Leary again. I want to dive a bit deeper into the properties of specific quadrilaterals. So if you have a shape and you know that it's a certain type of quadrilateral, like you know that it's a parallelogram because you're told it's a parallelogram, then there are other properties, other facts that you know will be true. So if you know that a shape is a parallelogram, and this is the definition of a parallelogram, a quadrilateral where opposite sides are parallel, then you can say, I know, therefore, that opposite sides need to be equal in length. To show you what I mean by that, let's draw an example to show this particular fact, this first fact, opposite sides are equal in length. I'll draw a parallelogram. Opposite sides equal in length show that the top is the same as the bottom and the left is the same as the right. So if you know it's a parallelogram, then you know that the top and the bottom have to be the same size. Further, opposite angles will be equal in size. So if you know the shape is a parallelogram, then these two angles have to be the same. And look at them. They look like they're the same, right? They look like they're both a little bit bigger than 90. But you don't have to look and guess. The law says that if it's a parallelogram, then you know that that angle is the same as that angle. And also, this angle is the same as that angle. Notice that to show that they're the same, I can include the same symbol on both corners. A mathematician reading that will say, oh, okay, this angle is the same as this angle. We also know, if it's a parallelogram, that the diagonals will bisect each other. Bisect. The word bisect means to cut into two equal halves. So, first, to show what that means, let's draw the diagonals. The diagonals go diagonally from one vertex to the opposite vertex, or to another vertex. So these are the diagonals. And this law says that if it's a parallelogram, that they're cut in half. If I get my pointer in a different color, maybe green this time. So this length here in a parallelogram is the same as this length here. These two lengths are the same. And to do that, to show that, I put this little symbol, tick, tick. That means that these two are the same length. It's cut it in two equal halves. And the same is true for the other diagonal. That is the same, length is the same as that length. We can do a similar thing for a rectangle as well. If we know that a shape is a rectangle, and this is the definition for a rectangle, then we can make these three statements. These three facts will be true for every rectangle. First, opposite sides will be equal and parallel. To show that in our diagram, the top will be equal to the bottom, the left will be equal to the right, and if I show the parallel part, I'm going to get a different color now, maybe back to red. So the top opposite sides, the top and the bottom, they are parallel. So the top is parallel to the bottom and the left is parallel to the right for every triangle. Not every triangle, every rectangle. Mr. O'Leary, that's not a triangle, that's a rectangle. So if it's a rectangle, opposite sides, the top and bottom, are equal, the same length, and they're parallel. They point in the same direction. Also, if it's a rectangle, diagonals bisect each other. So let's draw the diagonals, this diagonal and that diagonal, just like a parallelogram, they're cut in half. So in other words, this length here is the same as this other length here. And next, diagonals will be equal in length. This one's harder to show on a diagram, but we can still do it. The easiest way is to label the 4 points, A, B, C, D, the 4 vertices, 4 corners. A vertex is a corner. And then we can make a statement. Now, which lengths are the same? So AC is the same as BD. AC equals BD. So now I've started with a definition. We're given some facts that are always true for a rectangle, and I've shown these facts. In the next video, I'll show the other 3, but I want you to give the other 3 a go first. So the other 3 are square, rhombus, and kite. You'll find the definitions in your textbook. Give them a go first. I'll put them up here as well.